Okay, we are here to look at question 41, which gives us our field is the gradient of square root x squared plus y squared. And we're going around the region that's the half annulus with r between 1 and 3 and theta between 0 and pi. They ask us to find the circulation and the flux. Note this thing is conservative. How do I know? Because it's defined as the gradient of this function, so the circulation on the boundary is 0. Done. For the flux, we have a little work to do. Specifically, this field is xy over square root x squared plus y squared when you take the gradient. So the flux then becomes the double integral over our region of partial with respect to x of x over square root x squared plus y squared plus partial with respect to y of y over square root x squared plus y squared dA, which this becomes a little bit of work to sort this out, but it turns out to be the double integral over the region that we have of x squared plus y squared to the minus 1/2. It makes a whole lot of sense to switch this to polar coordinates. This is 1 over r. So we end up integrating 1 over r d theta. R goes 1 to 3, theta goes 0 to pi. The r's cancel, and we're just integrating 1 dr d theta from 1 to 3 and 0 to pi. And that turns out to be 2 pi. So there's our solution.